Hello folks, welcome to Process Engineering YouTube channel where we all will learn about process flow diagrams and piping and instruments diagram basics. What is a PFD? A PFD is the fundamental representation of a process that schematically depicts the conversion of raw materials to finished products without delving into details of how that conversion occurs. It defines the flow of material and utilities, and it defines the basic relationships between major pieces of equipment. In other words, a PFD is a diagram used to indicate the general flow of plant processes and equipment. The PFD displays the relationship between major equipment of a plant facility and does not show minor details such as piping details and designations. The symbols used in PFDs are generally based on the International Organization for Standardization ISO 10628:1997, referred to as flow diagrams for process plants, general rules. Even though a set of standardized symbols are in place, PFD symbols used may be common among plants. Others differ from plant to plant, and many are not those prescribed by the ISO 10628 standard. Generally speaking, PFDs are used as training tools to introduce plant personnel such as operators to certain operational units to which they have been assigned. As operators become familiar with the operational units, they graduate to the much more complex PNIDs. What is a PNID? A PNID is a diagram which shows the interconnection of process equipment and the instrumentation used to control the process. In the process industry, a standard set of symbols is used to prepare drawings of processes. The instrument symbols used in these drawings are generally based on ANSI/ISA's S5.1-1984, R1992. In plain terms, a PNID is a one-line schematic diagram using symbols to show piping, equipment, instrumentation, and interconnections between them. Each piece of equipment is shown along with its connectivity to other equipment. Each instrument and piece of equipment is shown by a symbol indicating its type: pump, sensor, valve, transmitter, etc., and a unique identification number or tag. PNIDs often look very complicated because they show so much information, but you don't need to be an engineer to understand it. A PNID does not describe the chemical reactions involved or provide any procedural or operational details. The following are some examples of times when an operator may need to check a PNID. Planning a job, a locking up before repair or replacement of a piece of process equipment, troubleshooting if a problem develops, processing hazard reviews. The diagrams below will give you a quick insight into the difference between a PFD and a PNID. Note the complexity and detail of the PNID as compared with the PFD. The only reason for showing any instrumentation on a PFD is to highlight the importance of a variable for measurement or control, not to explain how it is measured or controlled, or to illustrate where the instrumentation is located and what it is connected to. Instrumentation symbols on a PFD are limited and kept simple, therefore devices such as primary elements and sensors, transmitters, alarms, etc. can be omitted. PFD symbols have been standardized through the International Organization for Standardization. A number of standardized symbols that you may encounter are shown in the following slides. A PFD shows all of the major equipment that is part of the particular process shown. All major process lines are shown. Equipment is generally identified by name and number across the top of the diagram. Equipment such as pumps and heat exchangers usually carry some identification close to the symbol. As mentioned earlier, instrumentation is only shown where it affects changes to operating or design conditions, and only in very simplistic forms. PNID identification system. An industrial process plant has thousands of instruments, and each must be identified. Each instrument in a plant is identified by a name or designation by alphanumeric code or simply a tag number. The tag number tells us about the location of the instrument and what function the instrument performs in the process loop. For example, a common identification for a level indicating controller, an instrument which controls level in a vessel and also indicates the amount of fluid present, is LIC 100. Let's break down this tag number and examine it more closely to reveal a number of important details. Instrumentation identification, or tag number, LIC 100. The first letter, L, of the tag number indicates the measured process variable, in this case level. The succeeding letters, IC, reveals the instrument's function, in this case indicating and controlling the level. Process loop number, 100, gives us the plant area designation or location of the instrument. For example, loop 100 may designate the glycol flash tank area, and LIC 100 is the level controller on the glycol tank. All instruments associated with this glycol tank are all tagged with loop number 100. Functional identification. The functional identification, LIC, or what the instrument is intended to perform, is a universal standard. Examples are P for pressure, F for flow, and T for temperature. Note that the previous examples were first letters in the functional identification. If T is also used as a succeeding letter, TT, it means transmit. Therefore, a device labeled as TT is a temperature transmitter. Instrument identifier letters. Notes on instrument identifier letters. The measured variable is always the first letter, F for flow, L for level, T for temperature, etc. Analysis, A, is multivariable. In that analysis could be for BS and W, for example. Therefore, a written description of the type of analysis is required on the diagram. The modifier of the first letter is used to give more information on the function of the instrument. For example, totalize Q is used in the tag number FQI. This instrument is a flow indicating totalizer which measures flow, keeps a total of the amount of flow over time, and indicates that a flow is present at a certain instant. The succeeding letters reveal the purpose of the instrument. For example, alarm, A, control, C, transmitter, T, or valve, V. The modifier used in succeeding letters again describes the function of the instrument in greater detail. For example, high H is used in the tag LAH, which means level alarm high. Another example is LAHH, which means level alarm high high. The letter Y, used as a succeeding letter, means relay or compute or convert. There are many different types of relays, computing and converting devices, so a written description is often required on the diagram. This slide shows examples of instruments and functions using letter combinations. For example, describe the function of an instrument with a tag of TRC205. The measured variable is temperature and the function is to record and control temperature. The loop number 205 is a code which describes the plant area designation. The loop number is unique and the same loop number may not exist in two different process plants. Instrumentation symbols. Symbols are standard pictorials used to depict instrumentation on diagrams and drawings. The symbol aids in identifying the instrument and reveals the functional interrelationships. Symbols define signals used, instrument functions, types of valves, dampers, primary elements, and regulators, to mention a few. Line symbols depict the type of signal used to communicate between instruments and the connection to the process. Table above lists typical symbols used to produce P&IDs. The following P&ID examples illustrate a number of the fundamentals discussed. Thank you for watching this video. Do like and subscribe this channel for more such interactive videos.